Hi, so here we have equation x cube plus 2r plus 1 x square plus 4r minus 1 into x plus 2 is 0 has minus 2 as one of the roots. If the other roots are real, then the minimum possible non-negative integral value of r is what? Okay, so at first instance you would want to substitute x equals to minus 2 here and figure out the value of r. But what you'll realize is the r will get cancelled out. You'll get 0 is equal to 0 effectively. Okay, so that's not how you can calculate the value of r. Fine. So if minus 2 is one of the roots, let's say the other roots are alpha and beta of this cubic equation. It's a cubic, right? So there will be 3 roots. Now we know product of the roots of this cubic equation will be minus 2 into alpha into beta, and we know product of a cubic equation is plus minus minus times the constant term upon coefficient of x cube. So 2 upon 1 minus 2. So minus 2 cancels out. We have alpha into beta is 1. That means alpha is 1 upon beta, or beta is 1 upon alpha. Hence the roots of this equation are minus 2 alpha and 1 upon alpha. So the two remaining roots are basically reciprocal of each other. Okay. Next, let's talk about sum of the roots. Right. So the sum of the roots here is minus 2 plus alpha plus 1 upon alpha. And from here we know sum of the roots is minus the coefficient of x square upon coefficient of x cube. So minus of 2r plus 1. Fine. So we have here alpha plus 1 upon alpha is equal to minus 2r minus 2, and this minus 2 goes that side, becomes plus 2. Sorry, this is minus 1. Sorry. This is minus 1. And this minus 2 goes plus. So this becomes alpha plus 1 upon alpha is minus 2r plus 1. Multiplying with alpha all the sides, we have alpha square plus 1 is equal to alpha times of minus 2r plus 1, and bringing this term on the left hand side, we get alpha square plus a negative sign gets multiplied once it comes on the left hand side. This becomes 2r minus 1 times of alpha plus 1 is 0. Okay, this is what we have. Now since this is a quadratic in alpha and we know alpha is a real number, the roots are real, the other roots are real. Since the roots of this quadratic should be real, the discriminant should be greater than or equal to 0. So the discriminant here is 2r minus 1 whole square b square minus 4 into a into c. This should be greater than or equal to 0. So 2r minus 1 whole square should be greater than or equal to 4. Now if this is the case, what we have is, if 2r minus 1 whole square is greater than or equal to 4, taking square root we get 2r minus 1 should be greater than or equal to the positive square root of 4 but less than or equal to the negative square root of 4. Okay? Negative square root of 4 will be minus 2. So solving this, we have 2r should be greater than or equal to 3, and solving this we have 2r should be less than or equal to minus 1. Dividing by 2 we get r should be greater than or equal to 3 by 2, or r should be less than or equal to minus 1 by 2. Fine. Now the question is the minimum possible non-negative integral value of n. So if you consider this, r should be less than or equal to minus 1 by 2. So from here you will get only negative values of r. But what we want is non-negative value. So for non-negative values, we'll have to consider this range. R should be greater than or equal to 3 by 2. 3 by 2 is 1.5. So the value of r should be greater than or equal to 1.5. So the least possible integral value of r minimum integer will be 2. R should be greater than or equal to 1.5. So the least value, integral value greater than or equal to 1.5 is 2. So the minimum value of r here is 2. Thank you.